The lesson topic for this video is solving rational equations. So the steps for solving rational equations is very similar to what we've been doing with adding and subtracting rational expressions. We're going to first find the LCD, or least common denominator, for the fractions. We are then going to multiply each fraction, numerator and denominator, by the factor or factors that it is missing from the LCD. Then, since the denominators will be the same, we'll be able to solve the equation that is in the numerator. All right, we're going to solve the equation that's in the numerator. We can actually, at this point, just simply ignore the denominator. But we will have to then check for extraneous solutions, which is similar but different to the work we did with radical equations, and it will actually involve the denominator. We're going to look at what this looks like on the next slide, and then we'll look at some examples. Okay, so when we think about extraneous solutions, we have to remember that it is an apparent solution, looks like it is a solution to the equation, but it does not work in the original equation. So here is how that works for rationals. It's all about the denominator, okay? So if I had 2 over x, like this first fraction right here, so if I had 2 over x plus 1/2 equals some fraction, again, doesn't really matter, 3 over x plus 2, I don't know, making up something here. If I had that, what could the denominator right here not be? What can the denominator never be? Well, the denominator cannot be 0, okay? If a denominator is 0, it means we're trying to divide by 0, and we know that in mathematics you cannot divide by 0. So the question here is, what is the number or numbers that x cannot be in these expressions? Well, for this first one right here, since x is in the denominator, we know that x cannot equal 0. Because if I put a 0 in here, it would be 2 divided by 0, which we cannot do. We can't divide by 0. But in the second example, x can be 0, okay? Think about this for a second. If we put a 0 in for x, it'd be 0 plus 3 in the denominator, which is 3, so it'd be 4 over 3. Well, 4/3 is a completely fine fraction. So what number could we not put in here for x because it would make the equation 0, or the denominator 0, excuse me? Well, -3. So in this example, x cannot equal -3, because if I put a -3 in here, I'd have -3 plus 3, which is 0, which is 4 then divided by 0, and we cannot have that. So then how about this next one? What can x not equal here? Well, x cannot equal 1, because 1 minus 1 is 0. How about this one down here? What can x not equal? Well, usually when we get to things like this where there's a number in front of x, some people are able to really easily see what that value would be. Others are going to need to do a quick mathematical equation. And that is, we cannot have the denominator, 2x minus 1, we cannot have it equal to 0, right? So if I set it equal to 0, I would find the value of x that I cannot use. So if I add 1 to both sides, I get 2x equals 1, and if I divide that by 2, I get x equals 1/2. Okay? So because we get x equals 1/2, that means the value of x that we cannot have for this denominator is 1/2. So x cannot equal 1/2 here. If x is a half, when we solve our equation, this would be an extraneous solution because it would make the denominator 0. So why don't you go ahead and fill in what can x not equal here, and what can x not equal here? All right, so for the first one, this one here, there are 2 different values that x cannot equal. X cannot equal -2, because if x equals -2, we're going to put that -2 in here, we would get -2 plus 2, which is 0, and then 0 times anything would be 0. So x cannot equal 2, and x can also not equal 3. Again, if I put a 3 in here, 3 minus 3 is 0, that would become 0 for this factor. 0 times whatever this is 0. We can't have that. The last one, if we solved both of these for 0, again, x cannot equal 6. I think people can see that one a little quicker. Okay, x cannot equal 6 because 6 minus 6 is 0. And over here, x cannot equal negative 5 over 2, or in other words, negative 2.5. Again, if I set this equal to 0, I'd subtract the 5, and then I'd divide by 2. So x cannot equal negative 5 halves. And that is what we're going to pay attention to when we're trying to decide if we have an extraneous solution. More on that in our examples. Okay, so here is our first example of an equation, a rational equation. 3 over x plus 2 equals 6 over 3x plus 8. If you think about those steps that I had written down on the first slide that you probably jotted down, what we need to do first is find an LCD. The LCD for this, for these denominators, first thing we'd have to do is factor each denominator, and they are already factored. So our LCD is every factor of the first denominator and every factor of the second denominator that we don't already have. So x plus 2 and 3x plus 8. Now we're going to multiply each denominator by the missing parts of the LCD, so 3x plus 8 on this side. And if I multiply the denominator by 3x plus 8, I need to multiply the numerator by 3x plus 8 as well. And on the right-hand side, we already have the 3x plus 8, but we will need the x plus 2. And again, x plus 2 in the numerator as well. Alright, so following similar steps that we've used in previous lessons, now that we have an LCD, we probably will want to distribute this 3 here and this 6 here. And we get 9x plus 24, and we get 6x plus 12. Alright, now that, again, this is an equal sign right here, so we've got fractions set equal to a fraction. Once the denominators are the same, which they are, all we need to do is solve the equation that exists in the numerator. That equation right there. We don't have to pay any attention now to the denominators. So I'm just going to go over here and write 9x plus 24 equals 6x plus 12. And now we're going to solve this equation for x. I'm going to subtract 6x from both sides. I have 3x plus 24 equals 12. I'm going to subtract 24 from both sides. I get 3x equals negative 12. And lastly, we divide by 3. X equals negative 4. Now again, before I circle this as my answer, I'm going to make sure that x equals negative 4 will work in our original denominators and not give us an extraneous solution. If I put this negative 4 right here for x, what's negative 4 plus 2? Well, it's negative 2. The denominator of a fraction can be negative 2. It just cannot be 0. So this is fine so far. If I put negative 4 in right here, 3 times negative 4 will be negative 12. And negative 12 plus 8 is negative 4. Again, that is fine as long as it's not 0. So x equals negative 4. Okay, so let's try another example. First thing we're going to do, we're looking at a fraction plus another fraction equals another fraction. So we have a rational equation. We need to find the LCD. The first denominator is already factored, so is the second denominator, but we need to factor the third denominator. So we know, since a equals 1, we're going to factor with our two sets of parentheses. I'm going to go off way over here, find some space. The negative 10 is our c value, which is 1 times 10, and one of them has to be negative. It's a 10, sorry. Or 2 times 5, and one of them has to be negative, and these two right here add up to 3. So we need x minus 2 and x plus 5. Now we're going to come down and write our LCD. Our first denominator is x plus 5, so we need that factor. We do not already have the factor of x minus 2, so we're going to include the x minus 2. Looking at the third denominator, we already have the x minus 2 factor, and we already have the x plus 5 factor. So this is our LCD. We are now going to multiply each of our fractions by the missing portion of the LCD. We'll multiply the top and the bottom, the numerator and denominator. So I already have the x plus 5. and now I need the x minus 2 factor. So x minus 2 in the denominator to get the LCD, which means I need x minus 2 in the numerator as well. In our second fraction, this one right here, notice I spaced it out a little bit when I wrote it, so I'd have some space right here to write my missing factor or factors. We already have the x minus 2 factor. We need the x plus 5. So again, please make sure to put parentheses around that x minus 2. We need x plus 5 in the denominator as well as x plus 5 in the numerator. Now, in our third fraction, we already have the x minus 2 and we already have the x plus 5. Sometimes people are very eager to multiply the top and bottom by something, but we don't need to because we already have the LCD. So now every fraction has the same denominator. Once every fraction has the same denominator, we can simply solve the equation that's in the numerator. Now before I do that, I'm going to go through and distribute, like I showed on the previous example. I'm going to distribute the 3, I'm going to distribute the negative 1. So I'll rewrite that as 3x minus 6, and rewrite this as negative 1x minus 5. And now I am ready to solve the equation that's in the numerator. Okay, so what I have is I have this first fraction, I have this as the numerator, plus the second fraction, this is in the numerator, equals the third fraction, this part is in the numerator. So that's all I need. So 3x minus 6 plus negative 1x minus 5 equals 10. Alright, we're going to combine like terms. I have a 3x that's positive and a 1x that's negative. So together that gives me 2x. Got a negative 6 and a negative 5, which gives me negative 11. And it equals 10. I'm going to add 11 to both sides. I get 2x equals 21. And I'm going to divide by 2, running into my LCD down here. X equals 10.5. Whoops. Alright, now before I circle this final answer here, I'm going to make sure that x can be 10.5. Now if you think about it, what could x not be here? X can't be negative 5. No, it's not. X can't be 2. Well, it's not. And then we have the same factors again, so in no way will we get 0 in our denominator, so this is our solution. Okay, so here are 2 more examples, and what I'd like you to do is do at least one of them on your own. Okay, pick whichever one you want. I will show the work in a minute, and you can walk through and see if you have it right or if you can find a mistake. And then ask me in class if you aren't sure how you made a mistake, if you did. But do one or both and check to see how you did. Okay, so the solutions you should have come up with are x equals 1.875 or x equals 2 for the second example, and they both do work in the original equations. Let me know in class if you have any questions on these.